Hello everyone, welcome to this channel. This question is from Olympiad Pathfinder, Chapter 12, Build Your Understanding, question number 20. The question is, an ideal gas is trapped in a thin glass tube of cross-section area A between two metallic pistons that can slide without friction. Initially, the pistons stay in equilibrium a distance d apart. That is small compared to their diameter. If the pistons are given unlike charges, each of modulus q, what will the distance between them become? Electrical permittivity of the gas is, you read it as epsilon naught by there's a printing mistake, and atmospheric pressure is P naught. So let us solve this question. This is the diagram of the initial condition for clarity. So if we take two pistons are A and B, so on this pistons, metallic plate pistons A, the atmospheric pressure is acting from outside and the gas pressure is from inside. So we have notated it as initial condition PGI is the pressure of the gas inside the pistons A and B. So how much force this gas will act on piston A? So that we can write PGI into cross section area, and this pressure, since it will be acting towards the wall of the piston, so it will be in the left direction. So that is what has been shown as an arrow here. And on this plate, from outside, which force is acting? That is atmospheric pressure into cross section area, and this force in the rightward direction. So this arrow has been shown like this. For this plate to be in equilibrium, or the pistons to be in equilibrium, what should happen? The rightward force should be equal to the leftward force. So we can write Fg is equal to Fa, and we'll be getting Pgi is equal to P0. So initial pressure inside was P0. Now, this plate A has been given a charge Q, and as per question, equal and opposite charge has been given on the plate B. So what will happen? These two plates are charged now, so this will start attracting each other. And because of that, there will be movement of plate A towards B and B towards A till the time the system comes back again in the equilibrium. So let us say in this phenomena, final distance between the pistons was dF, and gas pressure has become PZF, pressure of gas in the final condition. Now we will take the free body diagram of plate A or piston A. So which force from outside is acting now? P0 into A. Which force from inside is acting now? That is acting in this direction because of the gas pressure into cross section area, PGF into A. And there will be one electrostatic force of attraction between these plates, so Fe. So we can, and since the system is in equilibrium, so net force on the right direction will be equal to the net force in the left direction. So we got this equation number 2. Now let us calculate for force, electrostatic force. Because of this plate, the E field will be in this direction, and the value of that E field will be sigma by 2 epsilon naught, as we have studied already, because of a plate and the distance is too small. So we can say that for that distance, this plate can be assumed as an infinite plate, infinite size plate. So sigma by 2 epsilon naught will be the electric field created by the plate B with the charge minus Q, and that will be in this direction. So sigma by 2 epsilon naught will be the E field, and if we multiply it with the charge on plate A, we will get the electrostatic force, so Q. Sigma is the modulus of the charge divided by the area. Sigma is the charge density, So we will be getting Q square by 2 epsilon naught A as electrostatic force on the plate A. That is equation 3. If we compare the equation 2 and 3, Fe we can replace with Q square by 2 epsilon naught A. So this equation will become like this. So PGF will become P naught plus Q square by 2 epsilon naught A square. If you notice, there is nothing mentioned about the process of compression of the gas in the question. So what we should think of, that during the compression, the heat which was generated and was changing the temperature of the gas has been dissipated through the metallic piston to the atmosphere, and the temperature of the gas was throughout the same. So we can consider this case as an isothermal condition. And since it is an ideal gas, so we can write when the temperature is constant, so we know that PI means initial pressure into volume initial will be the final pressure into volume final. Sorry. So PGI we have already calculated it as PO, P naught, that is VI into this. PGF we can put from this equation. And upon solving, we will be getting final volume as P naught into A into D divided by this. But VF will be what? The cross section area into the gap volume of gas will be the cross section area of the piston into the gap between the plates. So that is A into DF. So DF will be getting as 2 epsilon naught A square P naught into D in numerator and divided by, or in denominator you can say 2 epsilon naught A square P naught plus Q square. So hopefully you understood the concept of solving it. In case any doubt, please do write in the comment box. I'll clarify. Thank you.